Dear students, once again we are back in the chemistry class, and today we are going to start a new lesson. That is lesson number 4. It is about transition and inner transition elements. Okay, it's a very interesting lesson also, a lesson to be learned very carefully. We know about periodic table. So in the periodic table, it is like this. This is how the outline of the periodic table. We have group 1, group 2, group 3 to 12, then 13 to 18. Right? There are 18 groups according to UPSC rules. So first and second group are called as S block elements. 13 to 18 are called P block elements. 3 to 12 are called D block elements. And the one which is at the bottom is called F block elements. This we have studied in +1 itself. So why it is called like this? Because here, if you write the electronic configuration, the last electron will enter into S orbital. Here, the last electron will go into P orbital. And here, the last electron will go to D. And here, the last, in these elements, the final electron will enter into F orbitals. Right? Now, today's lesson is transition elements and inner transition elements. Transition elements are the elements which are placed in D block, right? And it is from group 3 to group 12. Whatever element that is present, it is called transition element, right? And the inner transition element is the one which is placed in F block. Right? The elements which are placed in F block or inner transition elements, the elements which are placed in D block are called transition elements. Right? So what is meant by transit? If you take the word literal meaning of transit, it is nothing but changeover. The transition elements are placed between S block and P block. So S block elements are metals, very active metals, right? And P block ends up with non-metals, right? So here the property, there is a transitional property. So transition elements are placed between S block and P block, and the properties undergo a transitional aspect as their property changes from metal to non-metal, electropositive to electronegative. Because of the changeover, they are being referred as transition elements. Within the transition elements, if we take the elements which are following after lanthanum and actinium, there are 14 elements which are taken from cerium to lawrencium, right? These 14 elements are being called as the lanthanides. Similarly, we have 14 elements following actinium will be called as actinides. These elements are being referred as inner transition elements. They are present within the transition elements, therefore they are being referred as the inner transition elements. So this is the general knowledge about this transition elements. So transition elements are nothing but D block elements. Inner transition elements are nothing but P block elements. To start with, we'll take up first the transition elements. Then we'll go to the inner transition elements. So transition elements right? Transition elements are D block elements. Right? They are present from the group 3 to 12. And third aspect is they are placed between S block and P block. So this is the important aspect of this transition elements, right? So the position of transition elements The first character that we are taking up is position of transition elements. So position already we have mentioned that they are present from group 3 to group 12 and they are placed between S block and P block. And they are called as series, 3D series, 4D series, 5D series and 6D series. 4D series is present in fourth period of the periodic table and it goes from scandium to zinc. Right? This is the 3D series. So when I say 3D series, they are present in the fourth period and they are called as the elements are from scandium to zinc. In this 3D orbitals are filled by the final electrons. Right? So this is called 3D series. Right? Similarly, if you take 4D series, it is present in the fifth period of the periodic table. It starts from yttrium and goes up to cadmium. Right? In this 4D orbitals are being filled up. So that is called 4D series. And 5D series is present in the sixth period and it starts from lanthanum and goes up to mercury. Right? In this 5D orbitals are being filled up. That's why it's called 5D series. And 6D series is present in the seventh period and it has got the elements from actinium, then rhafnium to cananites. Right? So in this 60 orbitals are being filled up. So fourth period, the 3D series, 4D series and 5D series are mostly the normal metals, whereas the last one is mostly radioactive metals, which are present in the 6D series. So there are 4 series which are present in the transition elements, and these 4 series are being referred as 3D series, 4D series, 5D series and 6D series. And we should know that each series has got 10 elements. Why each series is got having 10 elements? That also we should know. Because electrons are filled up in d orbital, therefore it will go from d1 to d10. The first element will have d1 configuration and the last element will have d10. Therefore there are 10 elements in each series. So this is regarding the position of the transition elements. The second aspect that we are going to learn is about the electronic configuration. And if you take the electronic configuration of transition metals, and it is very interesting to note right? For example, we will take the 3D series. So 3D series, the first element is scandium. After that we have titanium, then vanadium, chromium, manganese, iron, and after that it is nickel, then copper and zinc. Right? So this is called 3D series. Atomic number is 21, 22, 23, 24, 25, 26, 27, 28, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is scandium, titanium, vanadium, chromium, manganese. So one metal is missing. That is after manganese, iron, then cobalt, After that it is nickel, copper and zinc. Okay, so this is 26, 27, 28, 29, 30. Right? This is the atomic number. Now electronic configuration of this is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Right? This is how it goes. After this, it is 18 electrons, and this is almost taken as argon configuration. Argon is the inert gas which has got this configuration. Therefore, titanium will have argon configuration followed by 4s2, 3d2. Vanadium will have argon configuration 4s2, 3d3. And chromium will have argon configuration 4s2, 3d4. And manganese has got argon configuration 4s2, 3d5. And iron will have argon configuration with 4s2, 3d6. And cobalt will have argon configuration with 4s2, 3d7. And nickel will have argon configuration with 4s2, 3d8. And copper has got argon configuration with 4s2, 3d9. And zinc will have argon configuration 4s2, 3d10. Right? So in this, the chromium electronic configuration is wrong, and the copper electronic configuration is wrong. These two are wrong, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the 3D4, if you take the orbital distribution of electron, it is like this, right? If it gets one more electron, it reaches half filled. So according to Hund's rule, half filled orbitals are more stable. Therefore, in chromium, one electron will be shifted from 4s2, and this will be made as 3d5. And similarly here also, for copper, if you write the electronic configuration, it will come to d9. If it gets one more electron, it is completely filled. Therefore, here also, one electron will be generally shifted from 4s1 to 3d10. So particularly copper and chromium, you have to be very careful in writing the electronic configuration. What is these type of elements they will ask in the exam also, right? So we get D1, D2, D3. We should not get D4. There should not be D4 and there should not be D9. Both must be converted to half filled or completely filled, right? So this has to be kept in mind. Therefore, the general outermost electronic configuration is n-1, D 1 to 10, and ns 1 2. So this is the general outermost electronic configuration for all the transition elements. For 3D series it will be 3 and 4. For 4D series it is 4 and 5. For 5D series it will be 5 and 6. For 6D series it will be 6 and 7. So this is how it goes, right? So this is regarding the electronic configuration. So in the electronic configuration, D4 should be avoided and D9 should be avoided.